Alessandro will show you an introduction about locomotion controller and its integration with web applications. Locomotion is one of the more interesting products to come out in the past several years. If you have never heard of LEAP before, it's a new take on the computer user interface, essentially replacing or really working in tandem with the mouse. The locomotion controller device is a motion sensor that allows you to control your computer with gestures without even to physically touch anything. This sensor detects the movement of your hand and the device responds accordingly. It recognizes hands and fingers, reporting position, gestures, and motion. The locomotion controller is a tiny device that allows to detect positions and orientation of one or several hands. It can send to an application and skeletal tracking data like the position of each bone of the finger or the orientation of the palm of the hand. The locomotion controller senses how you move your hands, the way you move them naturally. So you can point, wave, reach, and grab, and pick something up and put it down. The locomotion controller is currently available over the internet and in all best stores. It supports a wide range of programming language as, for example, C++, Objective-C, C#, Java, Python, JavaScript, and it's not very expensive. This is my favorite slide. The locomotion controller tracks both hands and all 10 fingers with pinpoint precision and incredible speed. Gesture control is the latest step in the evolution of human-computer interaction, replacing traditional interface methods like keyboards and touchscreen. The locomotion controller doesn't replace your keyboard, mouse, stylus, or trackpad. It works with them and without special adapters. Using two monochromatic infrared cameras and 3 infrared LEDs, the device observes an spherical area to a distance of about 1 meter, and the LED generates a 3D pattern of infrared light, and the cameras generate almost 300 frames per second of reflective data. The locomotion system recognizes and tracks hand fingers and finger-like tools. The device operates in proximity with precision and frame rate and report discrete position, gestures and motion. The locomotion system employs right-handed Cartesian coordinate system. The origin is centered at the top of the motion controller. Okay. Now we will see some video. The first video shows how you move your hand with incredible speed. This is an official demo video. Okay. And now, the second video shows an example of a simple SAP Wi-Fi application. So JavaScript API, you can use the promotion controller. Okay. Okay. Now Alessandro.
Okay. Thank you, Patricia. Let's move on with our presentation. We identified some interesting potential uses of the device. For example, we're finding information retrieval in public places, hotels, airports, and malls, and other public spaces. Can enable visitors to manipulate, navigate maps, for example, zooming and in and out on details, and for example, changing orientation simply by pointing. Or interactive maps. There is a great example in here.com/list. Here.com is a global leader company on the mapping world, and this URL where we can see some examples to explore cities on a 3D point of view using the motion device. And of course, business presentation, we can easily integrate all the available frameworks that use HTML5 to perform presentation such as React.js. So using HTML5 to perform presentation, we can easily integrate via WebSocket the leap motion. So we can use leap motion to move to the right on the presentation. Interactive campaigns, marketing and interactive advertising can enable consumers to click through videos, images, play games, search content without requiring physical contact with screen. Other interesting examples are on surgery. There are some videos on YouTube with an application of the leap motion on surgery, also in Italy, in Verona, and to perform some activities without requiring the physical contact with the screen. Another interesting use is the software accessibility. So we can enhance the software accessibility using the leap motion device. This is an interesting link when describing how students with disability can use the lip motion with gesture recognition. So, depending of the student, we can define custom gestures. So, every student can perform some gestures. We can define for every student a custom gesture. So this is a picture, interesting image I got from the link, from this blog link. Another use is a picture I took at the train station in Rome a few days ago. So a real use. The sentence says, drag the bag to find the exit. Of course, this is not interactive, but this is an animation as a starting application. We could create a real advertising application with lip motion for dragging with the bag to find the exit. And this could we could create easily a sample HTML5 application. Development APIs. We have two options: a native development. There are SDK of Unity 3D focused on video game or 3D modeling, C++, Python, Objective-C, and Java. And then there is the WebSocket interface, so focused on HTML5 using the lip.js library. Our examples uses the lip.js library because in this way we can integrate the SAP Wi-Fi applications with the lip motion. Just simply adding the lip.js library in our SAP Wi-Fi project. Really important, lip.js is open source, so we can explore in the library on github.com/lipmotion/lip.js. We can start the library, we can fork it, we can download it. The architecture, lip motion use when we plug the USB, the lip motion via USB, lip motion creates start a Node.js server on localhost on this specific port. The Node.js server via WebSocket push the JSON message, a JSON message that can we elaborate via lip.js library. So via WebSocket we have Node.js server pushed directly to our web application. We are free to use the lip.js in any HTML5 web application. We can go to developer.lipmotion.com. There is the library version 2. It's still in beta, but we use this library in our example because it uses a new skeletal model. These are the gestures you can use, and the recognize movement as gesture, which could indicate user intent or command. The motion records gesture observed in a frame. In the same way, it records other motion tracking like fingers and hands. So we have a circle gesture, swipe, a case up, and very important, we can define our custom gesture using a tool, a web tool, to recording the lip motion gesture. So we can record our own gesture and use it in our HTML application. Okay. Now we'll see other demos. Now I'll try to plug the lip motion. So for people in Rome, we can see an example, but then we will see the video. So for all other people. Okay, now this is an utility JSON viewer in the lip motion SDK. So we can explore the JSON object pushed via WebSocket. So okay, we can see the movement, and we can also enable with function gesture, so we can, when a gesture is recognized, the JSON object stop it, and we can see the type of gesture. In this case, is wipe. We can go on. In this case, we have other gestures. And now we see video. Okay. We developed a simple HTML5 application where we can see how the gestures are recognized. In this case, we use the swipe. We catch swipe gestures to right, left, and up and down. This is a simple JavaScript application. Now we see a SAP Wi-Fi interaction. We use, of course, the lip.js library, and we use the lip global object with the loop function, and we can catch the gesture. We use the simple application to refresh some data, and with a circle, when a circle gesture is detected, we have a refresh of the data. In this case, we used a simple JSON static JSON object, but of course we can link a gesture to an AJAX request. So, for example, we can link a circle gesture to a call of a gateway service, or an AJAX request, or an XJS URL. So everything we want. And the last example is an integration with Google Maps. So we have a function called isGripped. So when the hand is gripped, we can move around the map. We use the Google Maps library. So when the hand is gripped, we can move, and we have the cycle in green. We use the Google Maps library, and the lip object is called online interface determined by the browser, and the demonstration frame of lip is passed to our camera function. We have a function to determine the state of if the hand is grabbed or not. If it's grabbed, we have the circle green. With the circle gestures, we have a zoom in or zoom out. When the hand is grabbed, we can move around the map. And now I'll try to find our office in Rome, via Salvatore Cosimodo, and this we can see the package. And with the circle gesture we can navigate to the zoom. We can zoom in and zoom out. And our latest okay. Okay. Our slide is the comparison between Kinect, Microsoft Kinect, and Leap Motion. Some difference. Kinect is focused on whole body tracking, so we have a wide sensor but weak sensitivity. Leap Motion has a nice sensitivity, but we have a sensor, a smaller sensor region. That's all. Thank you.